Which of the following functions is a solution to the differential equation y double prime minus 4y equals 0? Well, in order to do this, we have to find out what y double prime of these guys are and test them out. So let's start out with A, where y equals e to the 2x. Y single prime is going to involve chain rule. Okay, keep the derivative of the outside, which is e, or take the derivative of the outside rather, which is e, keep the inside, which is 2x, but multiply everything by the derivative of the inside, which is 2. Okay, now let's do it again. Y double prime, keep the outside, or take the derivative rather of the outside, which is e, keep the inside, which is 2x, multiply everything to the derivative of the inside. So 2 times 2 is 4. So let's test out to see if A works for you. Y prime is now 4e to the 2x minus 4 times the y that we were given is e to the 2x. 4e to the 2x minus 4e to the 2x does give us 0. It checks out, so A is going to be my answer. Now, if it wasn't, we would just try all of these and see what happens, but since A worked, we're sticking with A. Of the following, which are solutions to the differential equation y double prime minus 5y prime plus 4y equals 0? Oh, all right, so let's do this guy in red. We have y, right? So y equals 5 cos 2x. Now let's find y prime. Okay, the derivative of 5 cos 2x is going to involve chain rule, so 5 is just there. Take the derivative of the outside, which is cosine x, so negative sine. Keep the inside, but then multiply everything by the derivative of the inside. So you become negative 10 sine 2x. Y double prime is going to be negative 10. Take the derivative of sine, which is cosine. Keep the inside, but then multiply everything by the derivative of the inside. So you become negative 20 cosine 2x, and that should do it. So let's test it out. Okay, y double prime is negative 10. Nope. Negative 20 cosine 2x minus 5 times y prime, which is negative 10 sine 2x, plus 4 times y, which is 5 cos 2x. And I'm supposed to get 0 when I do all that. Now, quick math will tell you that the negative 20 cos 2x and the 4 times 5 is going to be positive 20 cos 2x. Those will go away, but we're going to be left with a 50 sine 2x. That doesn't disappear, which means it's not going to be 0. So 1 is not going to be an option. So get rid of you and get rid of you. Okay, let's try out option number 2 and see if that works. So option number 2 gives us a y of 2e to the x. This is easy. Y prime is also 2e to the x, and y double prime is also 2e to the x. So when we plug it into this guy, we have y double prime, which is 2e to the x, minus 5y single prime, so times 2e to the x, plus 4 times regular y, which is 2e to the x. I'm supposed to get 0. So 2e to the x minus 10e to the x plus 8e to the x is going to end up being 0. So 2 actually does work. Hooray! So that is a possible option, but we're not done yet because I could still get 3. So let's test out. It's not going to be 3 only, we know that, so if we want to get rid of you for funsies, let's get rid of you. Let's try that out. So some arbitrary constant c, so y is going to be some c e to the 4x. Y prime is going to have me keep e there, drop down the 4 to that c to the 4x. Y double prime is chain rule again, so drop down the 4, 16c e to the 4x. All right, so let's try this out one more time. Y double prime is 16c e to the 4x minus 5 times y single prime is going to be 4c e to the 4x plus 4 times regular y, so 4 times c e to the 4x, and my job is to get 0. 16c e to the 4x minus 20c e to the 4x plus 4c e to the 4x. 16 minus 20 is negative 4 plus 4 is 0 equals 0. So you work, which means you also work, which means the answer is going to be 2 and 3. Dos y tres. Very good. Given y equals k sine negative x plus 2 cos 3x, the differential equation 2y double prime because plus 18y equals 32 times the sine of inverse x. Find a value of k that satisfies the equation. So what I need to do is I need to find out what y double prime of, or what y double prime is. So y single prime is going to be k, you become cosine, take the derivative of the inside, throw it out front, make it negative, keep the inside the way it is. Great. Plus 2, the derivative of cosine is negative sine, so negative sine. Keep 3x there, but then multiply everything by 3, so that negative 2 becomes negative 6. So I will, oh no, I will write that all there. So we've got what? Minus 6 sine 3x. All right, let's do it again. Y double prime, we have negative k sine, because the derivative of cosine is negative sine, and then we're going to multiply everything by the negative. So a third negative is going to come out front, so we only need one negative lingering around, so let's get rid of one negative. There you have it. Okay, minus 6. The derivative of sine is cosine, so I shouldn't have written out sine. The derivative of sine is cosine. Keep the inside, multiply everything by the derivative of the inside, which is 3, so that 6 becomes 18. All right, so here we have it. We finally have our y double prime, and we have our original y prime, and we need to find out the value of k that satisfies this equation right here. All right, so 2 times that negative k sine negative x minus 18 cos 3x, close that, plus 18y, which is going to be k sine negative x plus 2 cos 3x has to equal 32 sine negative x. All right, so let's distribute. Let's do a little bit of distributive property. Negative 2k sine negative x minus 36 cosine 3x plus 18k sine negative x plus 36 cos 3x equals 32 sine negative x. U combine with U to make 16k sine negative x. U and U cancel each other out, and on the right side I have 32 sine negative x. In order to get k all by itself, let's divide both sides by 16 and sine negative x. Divide both sides by 16 and sine negative x. You cancel, you cancel, you cancel. And k is going to equal whatever 32 over 16 is, which is 2. Not a fun problem, not a fun problem at all.